Good evening, good afternoon, good morning, wherever I may be watching this from. This is Kanayas to be now with another segment of vectors under additional mathematics. As you can see, that is 26th December. Okay, unit vectors. Unit. When you think of the word unit, it means you are talking about something that is one. Unit represents one, a unit length. When we say a unit length, we are saying a length of or a length measuring to 1. So why do we say unit vectors? The first thing to point, unit vectors have a magnitude of 1. So that's the first thing to point, to note. Unit vectors have a magnitude of 1. So if you were to have the vector b is equal to, so in the previous videos we looked at how to represent vectors in the I and j format, and in this video we're just going to continue with that using the I and j format. You can have a vector b being equal to 3i plus 4j. That is our vector b. And then we are asked to find, or what is the unit vector of vector b? A unit vector is represented by the heart symbol. So it's like a heart symbol. When you see this heart symbol on top of the vector, they're trying to tell you that they are finding the unit vector of that particular vector. So you have this vector and you're told to find the unit vector. It means that vector b hat, the unit vector of vector b is equal to the vector itself, 3i plus 4j. You divide by the magnitude 3 squared plus 4 squared, which is equal to 3i plus 4j. You divide by the square root of 9 plus 16, which is equal to 3i plus 4j. You divide by the square root of 25. So vector b hat is equal to 3i plus 4j. You divide by square root of 25. Alright. When we say square root of 25, we are talking about the principal root. We are talking about the principal root. Principal root means we are only considering the positive root of the square root of 25. This means that when you are taking the square root of 25 and you are not solving an equation, when you are asked what is the square root of 4, square root of 4 is equal to positive 2. Not equal to a negative 2. That's something you need to know. So we do not say positive 5 or negative 5. The principal square root of 25 is positive 5. So you divide by positive 5. This will be your final answer. Alright. So there might be someone who may be wondering, what have you done right now? So what I simply did is, first of all, you need to know unit vector. The heart symbol, this is the heart symbol to represent the unit vector. So this is why I concluded like this. So we had our vector right here, we started there. And then we were asked, we need to find the unit vector of this vector. It means, first of all, we have this vector there. We divide by the magnitude of that vector, which is this. How do we find the magnitude of the vector? Finding the magnitude or the modulus of a vector is we get the x part, x component, we square it. The y component, we square it. So the I and j, I said these are the vector components I used to represent movement in the x-axis and movement in the y-axis. So it means that we just get the numbers and we forget about the I and the j. why do I forget about the I and the j? So there's a particular identity you need to know about I and j. I squared, which is equal to I times I, is equal to positive 1. J squared, which is equal to j times j, is also equal to positive 1. So if I were to write 3i squared, the I will be squared and it will give you a 1. The 3 will be squared and it will give you the 9. 4j squared. The 4 will be squared to give you a 16. The j will be squared and to give you a 1. So it's not necessary to write the I and the j at these phases. It's because we know I squared and j squared both equal 1. That is the identity you need to know for unit vectors. But another thing to note, if you want to make your life easier when solving past paper questions, you need to know unit vectors have a magnitude of 1. So this is how we find a unit vector of a vector. Hopefully that's clear. This has been another segment under vectors, unit vectors. Thank you so much for watching, and until next time, bye bye.